We're looking at lesson 4.4, solving equations with radicals, and we're eventually going to get to some more difficult radicals with radicals on both sides. The first problem, if you look on your guided practice, if you remember from our previous lessons and the steps for solving equations with radicals, the first step was we had to isolate the radical. Make sure that the radical's on one side of the equation all by itself with nothing else on the outside of it. And on this problem here, we have the square root of 4r. That 4r is both underneath the radical, so our radical's already isolated. The second step says you need to raise both sides to the power of the index of the radical. Well, our radical is a square root, so our index therefore is 2, and we have to raise both sides by 2. Let's see what we get when we do that. Well, the square of the radical cancels out the radical on the left-hand side, so you just have 4r. Now on the right-hand side, look what we have here. We have a binomial, the r minus 3, that's squared. Remember what you do when you have a binomial square? You need to write it out or expand it. Okay, the 4r is going to stay, but we need to multiply our two binomials together. You decide which method you want to use. I went ahead and used FOIL, but you can use any of the other methods. So my first 2r times r is r squared. Then I multiplied my inner and my outer, which I always know combines. Well, if I multiply even the inner, I get negative 3r, and the outer is also negative 3r. So when I combine them, I get negative 6r. And then I multiply the last. Negative 3 times negative 3 is a positive 9. Notice that you have a quadratic. The highest power is 2. When we are solving for quadratics, if there's no radical in your quadratic, you might as well go ahead and use the property of 0. So get the equation equal to 0. So we're going to subtract the 4r so that we can set the equation to equal to 0. Equals r squared. Combine the negative 6r and the negative 4r to get negative 10r, and plus 9. Now that we have the equation all set equal to 0, and we see that it's still a quadratic, our highest power is 2, we know that we should be getting two answers. So let's use the x factor. 9 goes on top, and it's a positive 9. Negative 10 goes on bottom. Because the 9 is a positive, that means that both the numbers that should be the zeros should be negative. And the two numbers that multiply together that equal 9 but add together to equal 10 are 1 and 9. So let's write this in factored form. Once we have it in factored form, we can solve the equation. So our zeros are, by the way, the zeros are the roots or solving for the solution of a quadratic all mean the exact same thing. So we set it equal to r is equal to the opposite of the first one, so it should be positive 1 or positive 9. Now, because we're working with radicals, we need to make sure we don't forget the fourth step. Check for extraneous solutions. So what that means is you have to plug your two solutions back into the original equation. You must do this whenever you have a radical in an equation. Just because it's a quadratic doesn't mean that both solutions may work. So let's try the first one. Write the original equation, but everywhere you see an r, replace it with 1. So I'm going to simplify that radical. 4 times 1 is just 4. Equals 1 minus 3 is negative 2. The square root of 4 is positive 2. And does that equal negative 2? No. Therefore, 1 cannot be a solution. Let's try the second answer. 9, so we're going to replace the r with 9 in all of everywhere we see the variable r. So 4 times 9 equals 9 minus 3. Simplify what's under the radical. 4 times 9 is 36. 9 minus 3 is equal to 6. Square root of 36 is 6, which does in fact equal 6. Therefore, 9 is the solution. So this problem right here has only one solution, and that's positive 9. Finish copying down the problem, and when you're ready, push play, and let's look at another example. Okay, ready for looking at number 2? Let's use our steps. The first step, we need to isolate the radical. Well, look where our radical is. We have a square root of b, but there's this negative b that's right beside it. So we need to get that to the other side of the equation by adding b to both sides of the equation. Now, you can't combine b with negative 6, so you're just going to have to write them side by side to one another. Because b is positive, I'm going to make that my leading term. I'm going to write b minus 6, like that. If the 6 was positive and the b was negative, I would probably rewrite it the other way around. Is equal to, well, the b's cancel out, so I should just have square root of b. Now I'm ready for step 2, where I raise both sides by 2 to get rid of the radical. Notice I have a binomial square on the left-hand side of the equation, so I need to expand it. Write b minus 6 times b minus 6 equals, and the square of the square root just equals the radicand, or the base, the b value. Alright, I have a binomial times a binomial, so I can use any of the multiplication methods. I'm going to use FOIL again. So first equals b squared. I multiply my middles and combine them all in one step. I have a negative 6b and a negative 6b, so that equals negative 12b. And then the last, negative 6 times negative 6 is positive 36. If you get stuck and you don't see how I combined and got that 12b real quick off the top of your head, then go ahead and push pause and you work it out with all the steps so that you can see where I get the negative 12b. If you still don't understand how to get negative 12b, then please ask an instructor to demonstrate it for you. It's equal to b. Now we have a quadratic that we need to set equal to 0 before we can solve it, so let's move that b over to the other side of the equation by subtracting b from both sides. Combine some like terms here, so we know that that is equal to 0. That was the whole point of moving that b. So we have b squared minus 13b, because we had a 12b minus a b, that's a 1b there. That's how we get the negative 13b, plus 36. Alright, now that we have this quadratic set equal to 0, you can see if your x factor works. 36 on top, negative 13 on bottom. Factors of 36, I couldn't see this right off the top of my head, maybe you could, so I'm going to go ahead and work them out. The factors of 36 are 1 and 36, that doesn't equal 13, neither does 12 and 18. By the way, I do know because it's a negative 13 that both signs should be negative, therefore these two numbers should add together to equal 13. So 3 and 12 don't work. 4 and 9 do though. 4 plus 9 equals 13. So those are my roots or my zeros. So we can write b minus 4 times b minus 9 and set it equal to 0. Therefore b is equal to, if you set each one equal to 0 and solve them, you should get positive 4 or positive 9. They're just the opposite of the root of the zeros. And those are the zeros. Whenever a question asks you what are the zeros of an equation, they just want to know the solutions. Like I said before, it just means the same thing. Now we're ready to check for those extraneous solutions. So we have to plug in the b of 4 into the original equation. So I'm going to write negative 6 is equal to, let's see if the rest of the equation is also equal to negative 6. So a negative b, we just said b is 4, so I write in the 4, plus the square root of b, which is 4. Alright, and we're ready to simplify. Negative 6 just carries down, negative 4 carries down, and we have plus square root of 4, which the square root of 4 is just 2. So negative 6, does that equal? We have negative 4 plus 2 equals negative 2. Those do not equal. Therefore, positive 4 cannot be a solution to this equation. Let's try 9. Don't always just assume that if one doesn't work, the other one has to be the solution. There is a possibility of getting no solutions for these if neither one of them work. So we have negative 6 is equal to, I'm going to replace all my b's this time with a 9. Carry down my negative 6 equals negative 9. Square root of 9 is 3, so I write plus 3. Copy down my 6 again. My negative 6 is equal to negative 9 plus 3 equals negative 6. And those do equal, yay, so that we found a solution. I'm going to show you 2 more of this type, just step by step with you, and then we're going to switch to a different type of problem, and then I'll give you 8 problems of both types that you can work on your own. Alright, if you're ready for number 3, first step, isolate the radical. We have a negative b that's outside of that radical that's on the same side of the equation, so we need to get rid of that first by subtracting b from or adding b to both sides. So we should have just square root of 7b minus 13, because those b's cancel out, is equal to, here I have a b and a negative 1. They don't combine, but because the b's positive, I'm going to write the positive first, minus 1 like that. Then I need to square both sides. We're on step 2. Square both sides to get rid of the radical after we've isolated it. That'll cancel out that radical, and you are left with everything that's underneath it. So 7b minus 13 doesn't change at all. Equals, there we have that binomial squared, so let's expand it. The next step, we will need to multiply those binomials together. So b times b is b squared minus 2b plus 1. And again, to get that middle term, let me just show you real quick where I'm getting that from. That's from the FOIL, the outside inside. So I multiply my outsides together, the b times negative 1 to get negative 1, and that negative 1, alright, negative 1 times b is negative 1b, and then I have another negative 1b that I combine together to get 2b. Just add them together. So that's how I get that middle term there. Now that I have this quadratic, I need to set it equal to 0, but if you look here, in the previous examples we just had one term that we need to move to the other side. In this example here we have 2 of them. We need to move that 7b to the other side. That's a negative 7b. We also need to move that 13, so let's put it as a positive 13, so that our left-hand side of the equation can equal 0. On the right-hand side of the equation, you need to combine like terms. We have the b squared, negative 9b plus 14. Now that it's set equal to 0, let's do the x factor. So c goes on top, b goes on bottom. Because you have a positive over a negative, we know we need both negative numbers. And the factors of 14 that equal 9, I can see it kind of in my head. It's 2 times 7. The only other factors would have been 1 times 14. That doesn't equal 9. So 2 times 7. So write this in factored form. B minus 2, B minus 7. Now that we have it in factored form, we can find the zeros, or the solutions. Oops, and I about wrote, I forgot to change the signs on those. I was getting ready to do this problem. So let's change those signs. That's supposed to be a positive 2 and a positive 7. Alright, now we need to check to see if both or just one of those solutions work. So let's plug in, oops, the 2. My previous example, I've already done this once. It must have erased. Let me go ahead and show you the 7. I'll go back and show you the 2. It did work. So I plug in 7 for everywhere I see a B. Notice that at the beginning of the problem it was a negative b. Be careful with that. That is a positive 7. I put it inside parentheses just in case it was a negative 7. So a negative times a 7, because that negative is on the outside, equals negative 7. 7 times 7 is 49, minus 13 is equal to negative 1. So bring down my negative 7. 49 minus 13 is 36, is equal to negative 1. Square root of 36 is 6. So negative 7 plus 6 equals negative 1. Opposite sign subtract, that's how I got that negative 1, is equal to negative 1, which is a solution. Yay, so 7 is. And let me go back for a minute so I can show you that 2 does work. So I just kind of erased a little bit so that I can fill in those 2's. So fill in a 2 wherever I see the b value, so plug in a 2 there and a 2 there. So we get negative 2 plus square root of 7 times 2 is 14 minus 13 is equal to negative 1. So negative 2 plus 14 minus 13 is 1 equals negative 1. Negative 2 plus the square root of 1 is just 1 equals negative 1. Negative 2 plus 1 is negative 1. And those do equal, so that's our other solution. A couple of different ways you could see a solution. When there's more than one solution, sometimes you'll see this curly brace symbol, and they'll just put the two numbers like this in order with a curly brace after it. That means a set. It means that both of these numbers are solutions. You may even see b is equal to like this with the curly brace 2 and 7. So those are the answers for number 3. When you're done copying it and following along, then go on to number 4 and I'll demonstrate that one for you. Alright, so this will be the last example that I show for you of this type. If you want to, you can continue watching for the second type of problems that I'm also going to do 4 practice problems with you on. Or you can push pause on the video after I demonstrate this problem, do problems 9 through 12 that are just like these, and do your self-check and correct afterwards to make sure that you understand before you watch the rest of the video for the second type of problems with radicals. Alright, for problem number 4. Alright, let's take a look at the last one. First step, as always, is to isolate your radical. This one, the radical is already isolated. So you need to square both sides of the equation and expand the binomial. The radical cancels out, so you get 51 minus 7x. You need to multiply the binomials together. Get x squared minus 18x plus 81 is equal to 51 minus 7x. Like in the previous problem, we have 2 terms that we need to move to the other side of the equation. It doesn't matter which way you go to make the one side 0, but if you've got 3 on one side and 2 on the other, it makes sense just to move the 2. So subtract the 51 from both sides and add the 7x to both sides. Combine your like terms, x squared minus 11x plus 30 is equal to, and that side cancels out, so it equals 0. Now that we have a quadratic, we need to use our x factor. C goes on top, b goes on bottom. Because you have a positive over a negative, we know the 2 numbers that we need both have to be negative. Factors of 30 that equal 11. Let's see, 1 and 30 doesn't work, 2 and 15 doesn't work, 3 and 10 does not, but 5 and 6 does. 5 plus 6 equals 11. So you have negative 5 and negative 6. Let's write the equation in factored form then. X minus 5 times x minus 6 is equal to 0. Our solutions then are the opposite of each factor, so x is equal to positive 5 and positive 6. Let's check to see if 5 is an actual solution that will work, so we plug it back into the original equation. 5 minus 9 is equal to the square root of 51 minus 7x, or 5. 5 minus 9 is negative 4. Square root of 51 minus 7 times 5 is 35. Keep on bringing down that negative 4. Square root of 51 minus 35 equals 16. Negative 4 is equal to, square root of 16 is positive 4. Negative 4 does not equal positive 4, so it's not a solution. 5 is not the solution. Let's try 6. Plug it into the original equation wherever you see an x. And then simplify. 6 minus 9 is negative 3. Is equal to the square root of 51 minus 7 times 6 is 42. Bring down that negative 3. Square root of 51 minus 42 is 9. Negative 3 is equal to, square root of 9 is positive 3. Again, negative 3 does not equal positive 3, so 6 is not a solution either. So the answer to this problem number 5 is no solution. And you'll need to write that, no solution. Another way you might see, especially if this was a multiple choice question on the ECA, you might see something that looks like this. It looks like a 0, but a line is through it. It might even have the symbol like that. But if you see a 0 with a slash through it in the diagonal, that's another way of writing no solution. So I just want you to be aware of that. Okay, I am going to stop this recording and start recording another one for the next 4 problems because it's a slightly different type of problem. If you want to stop and do problems 9 through 12 that are just like these 4 examples I did with you, you can do that and self-check yourself before watching the next video for the next type of problem I'm going to show you.